Assalamualaikum warahmatullahi wabarakatuh. My name is Nohar Izzat bin Nur Azizi. Nombor metrik AA 220041. We are from group 7 from section 1 and 2. We will present about force, mass and acceleration. Here is our content. First we have introduction, then theory, then example question, then discussion and conclusion. Here is group member. First we have Sufi Shukri, then we have myself, Nohar Izzat, and Zaim, then Amira and Anissa. Okay, first introduction. Force, mass and acceleration are fundamental concepts in physics that play a crucial role in understanding the behavior of objects in motion. Force, symbolized as F, represents any influence that can cause an object to change its motion. It can result from various sources such as gravity, electromagnetism, or applied force. Mass Mass denoted as m refer to the quantity of matter in object and determine its inertia. In other words, it measures an object resistance to change in motion. Then acceleration, represented as a, signifies the rate at which an object velocity changes over time. According to Newton's second law of motion, the acceleration of object is directly proportional to the net force acting upon the it and inversely proportional to its mass. This fundamental relationship allows us to understand how force and masses influence the acceleration of objects in the physical world.
For question 1, if the car in example 1 had a mass of 1 proton, what force was required to accelerate in a straight line at 1.6 m per s? What is the force? As you know, this is solution for question 1. And this is FBD for question 1. The calculation is mass m equals to 1.5 tons equals to 1.500 equals to 1,500 kilograms. Acceleration A equals to 1.6 ms. For Newton's second law, F equals to ma. F equals to 1,500 darab 1.6 equals to 2,400 Newton. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurhanisa. Okay, for question 2, lift accelerates with a man inside. A person of mass 65 kg stands on a surface scale inside a lift. What is the reading on the scale N when A, lift is stationary, B, lift accelerates upward at 2 meter, C, lift is moving upward at 4.5 meter, D, lift decelerates to the top floor at 2 meter, E, lift accelerates downward at 2 meter, F, lift is moving downward at 45 meter, G, lift decelerates to the bottom floor at 2 meter. Then for question B, F equals to MA, which is 65 times 2. Then we will get 130 Newton. This force is upward because it will accelerate upward. Now add them together. F total equals to weight plus force. Then we have to plus it, 637.65 plus 130, then we will get F total 767 and 0.65 Newton. For C, F equals to ma, which is 65 times 0, then we will get 0 Newton. So total force equals to weight plus 0. Weight equals to 637.65 Newton. For D, F equals to ma, uh, which is 65 times negative 2, we will get negative 130 Newton. This force is downward. So F total equals to weight plus force equals to 637.65 minus 130. Then we will get 507.65 Newton. For E, F equals to ma, which is 65 times 2, we will get 130 Newton. This force is in negative. This force is in negative 1 y direction, so it is also downward. F total equals to weight plus force, so 637.65 minus 130, we will get 507.65 Newton. Okay. For F, same as C, total F equals to weight plus 0. So weight, we will get 637.65 Newton. For question G, F equals to ma, which is 65 times 2. Then we will get 130 Newton. This force is upward because it is negative in downward, the acceleration in y direction. F total equals to W minus negative F. So 637.65 plus 130. So we will get 767.65 Newton.
Okay, we move on to the next part, that is discussion. An object can accelerate or change its state of motion as a result of force. It is measured in Newton and is commonly denoted by the symbol F. A push or a pull on an object may be compared to a force. Gravitational force, allelomagnetic force, and contact force between objects are only a few examples of the various sources of the force. On the other side, mass describes how much matter is contained in an object. It is measured in kilogram, kg, and frequently represented by the symbol m. Since mass is a scalar quantity, the gravitational field has no effect on it. Simply said, an object mass is a representation of its inertia or resistance to change in motion. A measure of how quickly an object's velocity changes is called acceleration. It is described as the rate at which velocity changes in relation to time. The vector quantity of acceleration is typically denoted by the letter a, meter per second squared m over s. Is unit. Acceleration can be zero when there is no change in velocity, negative when an item slows down, or positive when an object accelerates up. The relationship between force, mass, and acceleration is described by Newton's second law of motion, which states that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass.
In conclusion, the concepts of force, mass, and acceleration are intertwined and form the foundation of Newtonian mechanics. Force, as an external influence, can cause changes in an object's motion. Mass, on the other hand, represents the amount of matter in an object, and Newton's mass is resistant to change in motion. Acceleration measures the rate of change of an object's velocity, indicating how quickly its motion is changing. Newton's second law of motion reveals the relationship between these three quantities. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. This law allows us to understand and predict how objects behave when subjected to force. The study of force, mass, and acceleration is essential in fields such as engineering, physics, and everyday life, helping us comprehend and manipulate the physical world around us.
That's all from us. Thank you.